Guys, what's going on? Welcome back from spring break. We are jumping into Quadratics again. So we're week 5 online, and we're going to start reviewing some stuff. We already did Quadratics. This was the first lesson that we did in the semester as far as graphing Quadratics, although you guys had already been working with Quadratics the previous semester. So a lot of this should be review, but this was one of the toughest units that we've done, so we're going to jump back into it and take some more closer looks at some of the details and some of the important features of these things. So we're going to do Vertex Form right now, Vertex Form for Quadratics. And we're going to do two things. We're going to look at notes and some examples, and then we're going to take a look at the homework. Okay, so let's go ahead and jump in. Here's some notes. All right, Vertex Form review. So as you probably or hopefully remember, Vertex Form is one of the formats to put your quadratic equations in. So we also had trinomial form, and we also had factored form, and this is called Vertex Form. Well, why do you think it's called the vertex? Well, if you remember, there was something called the vertex of the parabola. And the vertex is this dot right here. Oh, hi, Daniela. Right here. And right here. This is the vertex. Right there, right there. So vertex form is good because it helps us to find where that point is. And if you may notice some things that are important about that point. For this parabola here, that point is the lowest. It's the lowest most point on the bottom of the bowl shape. And for this green parabola, it's the uppermost point. So we're looking at the vertex as either the very bottom or the very top. And also, there's these dashed lines. It says axis of symmetry. Symmetry. What's symmetry? Okay, well, symmetry is, I can zoom in on this. Symmetry is when things are the same on one side to the other. So for instance, my hands are symmetric, left and right. And so this side is symmetric to this side. Likewise, this side is symmetric to this side. So this little dashed line is showing us how we cut the parabola in half so that both sides are symmetric, like my hands, for instance. Okay, and as noted, the axis of symmetry always passes through the vertex. So there's a nice relationship between the axis of symmetry and the vertex, which we're going to look at. It's very simple and it's convenient. So we'll take a look at that. Okay, first thing, we're talking about the vertex, so let's just focus there. The vertex is HK. Well, what the heck's HK? Take a look at your formula. Here's H right here, and here's K right here. In other words, that this number H and this number K are the vertex numbers. This is your X value for the vertex, and this is your Y value for the vertex. So whatever coordinate we are, it's corresponding directly to these numbers here. And I want to point out to you the negative right here. This negative is important because it's negative H. What that means for us is that we're going to take the opposite of that number. We'll do some examples more detailed in a second, but just to look kind of real quick, if I give you x minus 2 squared, if I give you x minus 2, that's squared, then that means that our H value is 2. H equals 2. Now, what if I told you, if I gave you x plus 2? If I gave you x plus 2 squared, now we need to see, okay, does that mean that H is still 2? It's looking like it, right? You still have a 2 sitting right here. Let me get my highlighter back up. And I like that blue color a little bit better, this one. I still have my 2 here, so you might think that we're going to have an answer of 2, but it's plus 2. And the formula clearly says x minus h. So we have to think of this as x minus something. X minus something is going to give us 2. Okay, well, x minus negative 2 is going to give us a positive 2. So you can think of this algebraically, or you can just take it simply as it's the opposite. If you see minus 2, it's plus 2. If you see plus 2, it's minus 2. And there's good reason for that, but just to simplify, it's the opposite. K is not the opposite. Notice that there's a plus sign in front of K. So whatever K you see there, that's what it is. If you see minus 7, it's minus 7. All right, good. Axis of symmetry, this is the easiest part, I think. X equals H. Once you know what H is, You just literally write x equals that number, and then you got it. And that's your axis of symmetry. Simple as that. Nothing tricky about that one. All right. Scale factor, we're going to talk about the a, and then we're going to jump into some examples. So our a value is the thing in the front. We can see right here, right in the front of the equation. That's called our scaling factor. And you may remember scale factor from when we did dilations a little bit later. All right, so we see the scaling factor makes it narrow and it makes it wide. And you can read into this if you like, but the homework and the quiz for this week do not actually cover the scaling portion, but it does cover this. So this you can look at. I'm not going to spend time in this video. Let's focus here. If a is positive, the parabola will open up. Okay, well, this one's opening up, like the letter U. That's how you can remember up, or that the fact that it's pointing upward on both sides. So this one's opening up, and that tells us that our a value is positive, or vice versa. The a value positive means that it's up. And this blue one is opening downward. You can see that the ends are pointing in the downward direction. Down, down. So this parabola has an a value that is negative. So in this equation here, if you see a 5 in the front, 5 is positive, so it's going to look like this upward shape. But if you see negative 5 in the front, negative 5 is going to tell you that it's opening downward like this one. Or vice versa. If you see down, it means that that a value is negative. All right, well, let's see. I talked about maxes and mins just a second ago. I used the word bottom and top. For this upward parabola, the upward one, notice that the vertex, which is right here, is at the lowest most point. Now, there's a way to say lowest most point, which we can say the minimum. The minimum is the bottom, and then it comes back up again. Does this have a bottom? No, it doesn't. It just keeps going down, down forever. But it does have a top. It comes to some peak, and then that top point, that's as high as it gets. That's where our vertex is. So this is a maximum value. That's as high as we're going to get right there. So we know positive values for A mean up like this, and that gives us a minimum, and the negative values is down like this, and that gives us a maximum. Okay, just a quick review before we do the examples. The vertex is HK. H is always backwards or opposite. K is right here, not opposite. And the axis of symmetry is just x minus h. And we just talked about it. Okay, great. So let's go ahead and jump into a few examples. We're going to look at a few different types. And I'm going to go across. I'm going to do vertex, vertex, then axis of symmetry, kind of work our way down. Okay, vertex. I'm looking at H, and I'm looking at K. All right? I'm looking at H, and I'm looking at K. Okay, and I remember that the H value's got a minus in the front. And so that's going to tell me that it's the opposite. So when I see -7, I'm going to put a +7. And when I see +3, I'm going to put a -3. Now, K is not opposite. K says plus K. So that means we're not taking the opposite. So when I see +1, I'm going to leave that as a +1. And if I see +1 here, again, I'm going to leave that as a +1. And I'm making these coordinates because the vertex is a point. It's a particular point on the graph. So I'm going to make sure that I answer my question written as a coordinate point. So there we go. I've got my vertex for each. Axis of symmetry. Okay, that was the easy one. It's just x equals h. X equals, what's h? H was 7. Bam, done. Axis of symmetry, x equals h. What was our h value? 3. But it's opposite, remember? Always opposite. So -3. Notice it matches? Notice it matches? Yep. Notice it matches? That's got to happen. Why does it got to happen? Excuse my grammar. It has to happen because the vertex and the axis of symmetry pass right through each other. The vertex is always on the axis of symmetry. So these numbers have to match every time. Okay, opens up or down, max, min. We know we're talking about the A value now. Here's A. So our A value is 1/3. Do we care what the number is? No, right now we're just caring about the positive versus the negative. And 1/3 is positive. So that means that it opens upward. So I'm going to circle up. And is that a max or a min? Okay, well, if it's going up, that's going to be a low point. Up like this, there's a low point. So that's my minimum. Good. And then I'll look at this one. I've got a -4, negative. Negative means it's going down like this one. So that's going to hit like a top point, right? So it's going to open down, and it's going to hit a maximum value up here at the top. Okay, great. So we answered all those questions. Hopefully that makes sense. Go ahead and rewatch the video if you need more detail. Ask me questions in the comments or hit me up on a reminder, anything. I'm available for questions. A few more examples. These are going to be a little different. Identify the vertex axis of symmetry using the equation and graph. Okay, so very similar, but now we're graphing. So I'm going to just do one of these, and I'm going to show you how I want you to do this. I'm going to fill in the vertex, and I'm going to do this quick. If you don't know where these numbers came from, just wind the video back a little bit to where I find the vertex, wind the video back a little bit to where I find the axis of symmetry. But I know that these numbers have to match. I know that H is H, opposite. I know that K is K, not opposite. And I know that since A is positive, that is going to be a minimum. Okay, good. Now I have to graph it. That's the new stuff. How are we going to graph it? Well, the vertex we know is 3, -9. 3, -9. So I'm going to put down 3 minus 9 is down here. There we go. And I know that this is a minimum, so I know it's going to go up like this. And for right now, I am not going to be looking for a tremendous amount of detail. I really just want to see you graph it upward. Like, honestly, this picture looks pretty terrible. It's not even symmetric. But I will give you points for this because what I'm looking for right now is the correct vertex, the correct axis of symmetry, which I'm going to have you draw the axis of symmetry, and the right direction. So since I've drawn mine going up and I've got the correct vertex, I will get full points for this, even though the graph looks terrible and the x-intercepts are not in the right spot, because right now I'm not focusing on the x-intercepts. I'm really just focused on these things here. Okay, now, this type of question will also be on the quiz and on the homework. The graphs are already given. We're going to choose which one matches this equation. So let's look at our clues. I know that the A value is positive. And since the A value is positive, it should open up, open up, open up, open. Uh-oh, this one's opening the wrong way. So I know it's not that one. All right, next clue. What's my vertex? My vertex is going to be HK, which in this case is 2, 2. And so I will just look to see which one of these has a vertex of 2, 2. That one's looking pretty good. This one's -2, -2, so it's not this one. This one's -3, -2, so it's not this one either. All right, we did it. That's the one. Easy as that. And it really is easy as that, because the homework assignment, I already looked through, and the quiz, there's really not very tricky problems. They're pretty simple like this. And this one's the same. It's negative, so we're going to expect a negative A value. That means it opens down, so it's not this one. That would be a positive A value. And I've got a vertex of 4, 1. Okay, be careful. I'm purposely making a very common mistake. Remember that H value has to be opposite, so it's actually -4, 1. K is not opposite. So where's -4, 1? This is at, looks like 3, -3. That's not it. And I'm looking at the vertex. I'm looking at the vertex. I'm looking at the vertex. Here's the vertex here. -4, 1. Oh, that's probably it. Okay, but let's double check. I'm looking at the vertex, and I'm at -3, 1. Okay, that's not right. So we got it. The answer is C. Cool. That's it. If that made sense, then you can totally be successful in the quiz and in the homework for this week. This is what the homework assignment looks like. These questions are just like the one I went over a minute ago. The next page is very similar, where you're going to basically identify the equation that has the right vertex, pick the graph, and that kind of stuff. And you're going to notice that, I'll pick in the graph stuff. There are 12 questions, and I'm going to be grading the odd numbers only. The even numbers, I have the answers here. So you can check your work and make sure you're doing it right based on the odd number questions. I will be grading the even number questions whose answers I have blocked out. So you don't get to see the answers for the ones that I'm going to grade. Right. And I think that's it. I think that's all I want to talk about for this video. If you have questions, again, you can comment or you can hit me up on Remind, Google Classroom, however. And remember, the quiz is due by 2:30 on Friday, not 11:59 on Friday. It closes at 2:30 on Friday. So be sure to get that in as soon as possible. All right, that's it for me. I will see you guys next week.